Hi guys, so today we're going to go over FRQ 2007. This FRQ actually got a really low national average, and so we're going to kind of get into why that happened and how we can fix that score and see how we can improve ourselves on these kinds of problems. And they're very different than a lot of the other FRQ problems. That's probably why lots of people got very low scores, and obviously lots of people had to get zeros for it, the average to be less than 1. Okay, so let's start the FRQ. We see that there's a chart on the top, and we see that we're given x values where there's also f of x, f prime of x, g of x, and g prime of x. This shows that we're probably going to do some type of derivative problem because of these primes, and also that the function that we're going to be looking at will probably be some type of composite function. So let's look at the question. The functions f and g are differentiable for all real numbers, and g is strictly increasing. The table above gives values of functions and their first derivative as selective values of x. The function h is given by h of x is equal to f of g of x minus 6. So let's look at part A. Explain why there must be a value r for 1 is less than r is less than 3 such that h of r is equal to negative 5. So we're going to be, just based off of what it looks like, this question, we're going to be using some type of theorem. So what we're going to do first is try to define the endpoints of 1 and 3, the y values of the endpoints of 1 and 3, just because we have a y value here, negative 5. So we have h of 1, and that's just equal to f of g of 1, the function's right here, minus 6. And that's equal to, we have to look at the g of 1, so g of 1 is 2. So f of 2 minus 6. F of 2 is equal to 9. And we get 3. Now we have to look at h of 3, which is the other endpoint. So f of g of 3 minus 6. G of 3 seems to be 4. So f of 4 minus 6. And then we have f of 4 is equal to negative 1. So negative 1 minus 6 is negative 7. So our y interval will be from 3 to negative 7. Now we have to kind of choose a theorem to kind of prove that h of r can equal negative 5. So a theorem we want to prove is that the function, our unknown function, we don't have it drawn, will hit negative 5 at some point. And the theorem that we're going to use is called IVT. IVT is also called the intermediate value theorem, but you can always use its initials and everybody will understand what it is. So here's a picture describing the IVT. We have h of 1 is equal to 3 and h of 7. H of 3 is equal to negative 7, and we don't know what the function looks like, so we can guess what it is. But what the IVT says is that if it's applicable, we can say that if between the y ranges will hit all y values. So the three things that the College Board needs to see so that you can prove IVT is, one, that the value right here, h of r, is in between the values of the endpoints, which it is. H of 3 is less than negative 5, which is less than h of 1, or negative 7 is less than negative 5, which is less than 3. The second thing we need to show is that h is continuous on the interval from 1 to 3. And we know this because it says right here the functions f and g are differentiable, which also means that f and g are continuous, and because h is a composite function of f and g, it is also continuous. So we know that h is continuous on the interval from 1 to 3 because f and g are. The third thing we need to show is that we just need to explain what we're proving. So by IVT, which is the theorem, there is an r value between 1 and 3 right here, where h of r is negative 5. And that's all you have to say to prove this. Let's move on to part B. So part B says, explain why there must be a value c for 1 is less than c is less than 3 such that h prime of c is equal to negative 5. So if you remember our theorems, this theorem looks like, since we have this prime, we're going to be most likely using the MVT, which is a little bit different than the IVT. This is the mean value theorem. So what the mean value theorem says is that if we have this graph, like it's very similar to the last one, Um, the secant slope right here, the secant line, the secant slope, um, if this whatever the secant slope is, there should be another point on the graph where the tangent line is equal to that the slope of the tangent line is equal to the slope of the secant line. So to prove this, to make the College Board happy, we have to show three things. The first of which is that h of x is continuous and differentiable on the interval 1 is less than r is less than 3. And we basically proved that last time with the f and g being composite functions of h. The second thing we need to show, which is part of the NVT itself, is that the secant, find what the secant slope is. Thus, the secant slope is just equal to h of 3 minus h of 1, which are the y values, divided by 3 minus 1, which are the x values. And this is equal to negative 7 minus 3 divided by 3 minus 1, which is equal to negative 10 over 2, which is equal to negative 5. So that's their slope of the secant line. And we must prove that there's some tangent line, which is basically h prime of c, tangent line slope, that's equal to negative 5. And the way we just state this for the College Board is, by MVT, like what we did for IVT, there exists a c between 1 and 3 where h prime of c is equal to negative 5. And that's all we have to do to conclude. Okay, so let's move on to part C. So part C says, let w be the function given by w of x is equal to the integral from 1 to g of x of f of t dt, and we have to find the value w prime of 3. So the first thing we're going to do is find w prime of x, and this is just equal to d dx, which is basically taking the derivative of this function wx, which is just g of x ft dt. And we've done this many times, but this is just simply you plug in g of x for the t, so f of g of x, times the derivative of that function g of x. And we can actually prove this. I'll do it really fast, just so you can see. Basically, it's the derivative of the inside, which you could do f, which is basically the antiderivative of the lowercase f function. And you see that the integral is equal to f of g of x minus f of 1, which is just the calculus theorem. And that's equal to, if we take the derivative, just this inside, f of g prime of x. But then we have the inside function, which is times g prime of x. And f of 1 is actually just a number. So when we take the derivative of it, it's a constant. So when we take the derivative of it, it will be equal to 0. So we've basically proven that this is true. And if we plug in 3 into that, f of g of 3 times g prime of 3, we see that it is f of g of 3 is 4 times g prime of 3, which is 2. And this will just equal f of 4, which is negative 1, times 2, which is just negative 2. And that's just going to be our answer. Okay, so let's move on to part D. So D says if g negative 1 is the inverse of g, write the equation of the tangent line of the graph y equals g negative 1 x at x equals 2. So if we want to find the tangent line, we basically want to find the slope of y, and that's just y prime. So we want to take the inverse of the derivative of the inverse function g negative 1 of x. So we must use the equation, the derivative of an inverse function, d dx of f negative 1x is equal to 1 over f prime of f negative 1x. So we can apply this to g, and basically all you get is 1 over g negative 1 of x. And then we want to plug in 2 for x. As seen here. And to do this, we basically find what most people mistake is we find the g of x2 because of the switch for an inverse, and we correlate it to the x value because the y value is the x value when you have the inverse and they switch. So this is basically equal to 1 over g prime of 1. And we see that g prime of 1 is just that 5. So that's our slope. Now we can plug everything into slope form using the point that we just used, 2, 1 for the inverse function. So we have y minus 1 is equal to 1/5 x minus 2. You could just leave it in that form.